Hi folks, and welcome back to day 27 of 90 Days of DevOps 2024. I'm Daniel, I'm a platform advocate with NetWay's web services from Germany, and I will show you today how you can go from automated to automatic infrastructure management with Ansible. If you want to follow the demos, you will need to check out the official 90 Days of DevOps repository on GitHub, because all the information for setting up your lab environment and following through with the labs will be there. But let's get started. If you've never heard of Ansible, you might ask yourself now what it is, what it does, how it does what it does. So let's get those questions out of the way first. Ansible is an automation tool for IT services and IT service configuration. It works via SSH, which also means it is agentless, which is a very nice feature in my opinion, because that means you really only need to manage one central Ansible instance and no agents throughout your whole infrastructure. It's built or written in Python and configured with YAML, a quite common configuration language these days. And being built in Python also means that it's quite easy to extend it with your own functionalities should you need to do so. It's also completely open source and quite easy to get started with, as we will see in one of our labs later on. Ansible uses so-called inventories to keep track of your hosts and host groups. There is one default inventory on each system, which Ansible uses to look up your hosts on. You can also define your own inventories, of course, using YAML or ini files, as you can see on the right side. And you can dynamically create inventories from different providers should you want to do that. Inventories can also contain custom variables of your IT landscape, so you can give your hosts and host groups certain attributes, certain things to take into account when you then go on to manage your infrastructure with Ansible. The next thing we're going to have a look up is ad hoc Ansible, which is the very much easiest way to use Ansible from the CLI. You can run so-called ad hoc commands on hosts and host groups. For this, you need to specify a host group you want to modify, which will then be looked up in the inventory file you passed on to the CLI. You can specify the module to run. In this case here on the right side, we are using the package module, which is used to install or update packages on your managed systems. And we can pass additional arguments. In this case, we tell Ansible to install the package, which is defined in our host variables called web service. And now it's time for our first demo and try this command hands-on. In this first lab, we are going to try out Ansible ad hoc commands from the CLI ourselves. I already went through the setup process, so I already got Ansible version 2.15 installed. I got my host file, my inventory written. As you can see, I got two groups here, web service and EDA controller, which will be used in the later labs. And within the web server group, I in turn defined two hosts. One is called web shop, the other one is called company, with the respective web server package I want to install. Those are different because if you look at the web shop machine, it's running Ubuntu, and the company machine is running Rocky Linux, so different base OSs, but both can be managed with Ansible, no problem. With all this setup done, I should now be able to do something like this, as we already saw in the slides. I tell Ansible which inventory to use, which is hosts.yaml. I tell Ansible which host group from this inventory to use, which in my case is web service. And then I tell Ansible which module to execute, which would be Ansible built-in package. And I pass some extra arguments, which would be the name of our package to install, which we saved in the variable web server. Then I'll shorten the output. And with this done, I can now go ahead and execute this. Upon first execution, this will take a short moment because Ansible will collect so-called facts, which is basically meta information about the host it is supposed to manage. And then it will go on and install our packages on the systems, as we can see happening right now. So on the company system, this seems to have worked. The web shop system might take a bit longer. I don't know why, but there we go. So as you can see, the output for those systems differs a bit as well, but the result is the same. So in Ubuntu, I can check for the installed package by grabbing for Apache 2, and we can see Apache 2 has been installed, and the same on the Rocky Linux system with HTTPD. And here we can see as well, HTTPD has been installed. One of the nice things about Ansible is that it's idempotent. So that means if we execute the same thing again, we don't expect Ansible to change anything because we are already in the desired state. So let's issue the same ad hoc command again and see what happens. And we can see this time we don't get an output indicating a change, but we get a success, which basically means Ansible found the system already in the state we desired it to be. That's great. That's perfect. Let's try another command, shall we, to have some variety in here. So this time, I'm not going to use the package module, but instead I'm going to use the service module, which is used to handle systemd services on different systems. And once again, I'm passing the name of our service, which is the same name as our packages or web service we just installed. And I pass an additional argument, which declares to Ansible that we want our web service to actually be in a running state, to be started. If I issue this, we can see once again a different output. So on web shop, we get a success state. That probably means that on Ubuntu, Apache 2 gets started right away upon installation. And on Rocky Linux, on our company host, we get a change state, which means our service for HTTPD got started now. We can check that easily with curl. So I can go and check on my web shop machine, and I get an answer by Ubuntu and Apache 2 somewhere around here, yes. And if I curl my company system running HTTPD on Rocky Linux, we get a similar output of Rocky Linux. And somewhere here should be something about, yeah, HTTP server. So this is HTTPD answering our request, which means everything worked as we'd expect it to do. For good measures, let's try the same command again. This time we should get 2 success states because both of our services are already running, and this looks quite good. Now that we've seen how we can use Ansible to manage our IT systems from the command line, we need to ask ourselves if this way of handling Ansible scales. And the quite obvious answer is no, it doesn't. We can't pay an operator to sit on his PC 24/7 typing in Ansible ad hoc commands, right? So we need a way to actually persist those ad hoc commands into an automatable format for Ansible to read. And this is where tasks come in. Tasks are the building blocks of what we call declarative Ansible, where Ansible handles all the things itself. And you can see an example here on the right. We have a name for the task, which makes it easier for the human operator and logging and so on to identify what is actually going on. We then need to define a module just as we would in an ad hoc comment. In fact, this example does the same thing we just did in the last lab. You can pass arguments just the same. Here we are defining the default state explicitly, which is that we want the package to be in a present state. And we can add additional aspects of the task. For example, we can tell Ansible to execute whatever it does in as a super user by passing become true, and we can also add conditions when to execute the task. One task alone still doesn't make for an automated way of handling things though, so we want to collect more and more tasks and group them together to abstract the actual things and everyday tasks we need to do on our infrastructure. And this is where Ansible provides roles and collections for us, which are two concepts to organize our tasks into different kinds of groupings. Roles can take both task definitions in YAML and additional Python code, so-called plugins, which extend Ansible's capabilities and package them for us to consume. Then again, collections are the next level, which actually bundle one or more roles. So let's say you want to automate and manage your Docker installations on different hosts, then you could find a community-provided Docker collection for Ansible, which has different roles for managing containers, Docker Swarm, the installation of Docker, and so on. And there's also a publicly available repository for collections and roles, which is called Ansible Galaxy. And in the bottom, you can see an example of how we would, for example, install the Kubernetes collection, which would allow us to manage our Kubernetes clusters using Ansible. Now, we already mentioned plays and playbooks and how they make up roles and go on to collections, but what do they look like? So a play is a collection as tasks, as already mentioned, and just like tasks, plays take names once more to more or less just inform the operator and make it easier to log things. You can then go on and define a host group to scope the execution to just a certain subgroup of hosts. And you can define pre-tasks and post-tasks to run in the beginning and end of your plays, as well as roles to execute, which then do all the main work for this play. You can also define variables not only on the task level or in your inventories, you can also define additional variables on a play level to make them last and valid for only the time this play is being run. And if we collect more plays into a single file, we are talking about a playbook. Once again, you've got an example on the right side. And the next thing we are going to do is try out and create a play and a playbook ourselves hands-on. So for our second lab, we are going to have a closer look at Ansible Playbook, which is Ansible CLI for running playbooks and the contained plays. And if you followed along the setup, cloned the repository, and so on, you will actually have the example playbook we are going to create already readily available. However, I will go on and write it from scratch to explain a few things while doing so. So if you look into your playbooks directory, there will be a playbook called example.yaml. If you open this, you will already have the fully working example, and I will go along and write my example out now. So we're gonna start with a task and we give it a name. I'll call it example role execution now. And we need to define which hosts will be affected, which hosts will be executed. And once again, I'll go with our web service group just so we have more output, 2 hosts and not just a single one. I'll disable the gathering of facts, which would happen in the beginning of all this metadata because we already did this in the first lab. And I will define one play variable, which will be a greeting. And traditionally, this should be hello world. Then we're gonna define pre-task. Pre-tasks are tasks which are run before the roles and tasks defined in a play. And so they are always running first. And we can use this opportunity to greet the operator running this playbook. For this, we're going to use an Ansible built-in module called debug, which is basically like console.log in JavaScript or print in Python. It's just a way to print strings and variables to the standard output. And we're gonna pass a message which will contain our greeting. Then we can go on and define our roles. And if we take a look at the repository again, we see there is this roles directory, which contains two roles. One's example, which we use for setting everything up. One is ADA, which we use for setting everything up. And one is example, which we are going to be referencing now. We can have a short look. In example, there is a task subdirectory, and we see it contains 3 tasks, which this role encapsulates. Task 1 gets the time and date on a host, task 2 gets the name of the host, and task 3 outputs those information to our logging solution. So let's get back to our playbook. We can define this local role called example, and then at the end of our play, we want to say goodbye to our operator. Once again, we're going to use Ansible built-in debug and pass another message, goodbye. This is it. It is as easy as that. And now we can run this one using Ansible playbook instead of just Ansible and pass the playbook. We also need to pass our inventory file again. And with this, we should be able to run it. We already see the output coming along nicely, and it's done because we didn't actually do anything intensive. We didn't need much power for doing so. We got our greetings here in the beginning because it's a pre-task that runs first, say hello on both hosts. We then get the time and date on our host, which has no output because we are just fetching information before we output it to our task output here. And then in the end, we have the post task say goodbye, greeting us once again. We also see that the formatting is a bit different from Ansible. We get this nice overview of which play we are running right now, which task within the play we are running, and we get a play recap as well, which tells us how many of the tasks for each of our affected hosts were successful, where we changed things, where hosts were unreachable, where tasks were failed or skipped. And this is already a much nicer experience to work with than running ad hoc commands with just Ansible. Now that we're all on the same page regarding what Ansible can do for us, how it helps us managing infrastructure and configuration and how it achieves that, it's time to go back to the title of this talk, from automated to automatic. Why would we need event-driven infrastructure? So where's the advantage in using Ansible in an event-driven way compared to what we saw right now, an operator executing playbooks manually, or maybe scripting a solution like a cron job that applies the playbooks on a schedule? Well, the answer to this, to the question why event-driven, is quite easy. If we look at DevOps and the software development lifecycle, automation already is reality. If we look at how we run tests, build software, deploy our software, and manage our infrastructure deployments, most of this happens automatically via CI/CD pipelines with intricate systems, automatical scaling here and there. But then day 2 operation arrives, and most of the time what we need to do there, maintenance and incident response mostly, is not automated. It's still done manually in many companies, many organizations. The bad thing about this is, especially the tasks which come up in day-to-day operations and day 2 operations are quite repetitive and predictable. You could think about things like running backups, pruning old backups, restarting services should they occasionally fail, scaling infrastructure up and down, providing more disk space for your service in your server room, and so on. And the bad thing with humans and repetition is we get bored and we are prone to human error the more bored we get. So it would make total sense to automate those incident response maintenance tasks in our day-to-day operations. And this is where event-driven Ansible can really help us, because many of those tasks I just mentioned are quite easily automatable with Ansible. And all we need to go from automated to automatic maintenance with Ansible is a way to trigger these tasks upon external events. And this is what event-driven Ansible was designed to implement and to solve for us. And let's go ahead and have a short look at the architecture of event-driven Ansible. At the core of event-driven Ansible is the so-called event-driven Ansible controller, which listens to webhooks and evaluates the received data according to rules configured in a file called a rulebook. So in this example, we can see our ADA controller is actually listening on 3 different ports. For example, for generic webhook events posted on port 5000, as explained here with the curl example. It could also receive alerts from Prometheus and Alert Manager, or things like your CI/CD pipelines that might trigger additional events. It then takes those received events and their data and parses them using the rulebook, evaluates if actions need to be taken, and if so, it will use the locally available playbooks and inventory files to trigger Ansible runs using another component of the system called the Ansible runner. If we now look at rules and rule sets a bit more in detail, we can see that they are quite similar to our plays and playbooks in traditional Ansible release. So rules are a set of sources, events, and actions that combine into event-driven Ansible runs, so to say. So same as tasks, they can have a name, and they can define a scope of hosts that will be affected by triggered actions. And then we need to define sources. And this is actually where our webhook configuration takes place. So here we can tell event-driven Ansible to, for example, listen on port 5000 on the local interface or on the public interface for incoming webhooks. It then takes a set, an array of rules that can be defined, which are then taken by the event-driven Ansible controller to evaluate every incoming event in turn and triggering the configured events should the condition match. In this lab, we are going to have a look at the event-driven Ansible controller, its setup, and how to trigger really basic rules and events just using curl and a basic webhook receiver. So on the EDA controller system set up by the lab environment, we already have our event-driven Ansible controller running. As we can see here, it's active. It started the controller. That looks quite good. And if we now go to the EDA controller's configuration, we can see there are 3 files. One is the inventory, which only holds localhost right now. One is an example playbook for a later lab, which will be able to restart a MySQL database server. And the third one, and the most important one for now, is the so-called rulebook. And we can see there are 2 top-level entries, 2 rule sets being defined, the second larger one being once again for the second lab to follow. And the one we're interested in right now is the first one. We can see there's one source being defined with a webhook receiver listening on port 5000. And we also defined one rule which always evaluates to true and will just print the output of the event to the journal, to the system journal. So let's see this in action. If we follow along the logs of the ADA controller like this and spin up another terminal, we can try and curl. It's on the same server, so we can just call localhost. We can try and curl this endpoint, this webhook receiver. I will pass some data. And with this, one thing that's important is to actually hit the endpoint. Otherwise, event-driven Ansible won't pick up on the webhook being sent. And if we send this, we'll get a very small answer. But if we look over to the logs, we can see that event-driven Ansible actually not just received our event, but also went through with its rule, because it's printed the whole payload, the whole events data, including metadata and so on, to our journal. So somewhere around here, we should be able to see, yes, the payload as well with foo bar. So this is the part we sent, and then event-driven Ansible enriches the registered events with metadata we could then in turn use to parse the rule sets. So this is how event-driven Ansible works. You basically set up webhooks and send JSON payload to those webhooks. And in the next lab, we are actually looking at a more real-world example where we will be using event-driven Ansible to restart services upon failure. The last lab is a bit closer to a real-world scenario where we have a service going down and we want to restart it using event-driven Ansible and automatic event handling of alerts generated by Alert Manager. So if you followed along the setup, you will have not only the event-driven Ansible controller on your VM, but also Prometheus and Alert Manager, which are already set up to monitor a locally running MySQL database server and an Alert Manager to alert in case of failure of the service being stopped for whatever reason. So we can observe this in real time by just stopping the MySQL server. And I'll also stop the event-driven Ansible controller so we get a bit more time to look at things while the downtime is actually happening. So within a few seconds, MySQL should go down and Prometheus should pick up on this here. And we did it. We can see now MySQL is in a down state. Prometheus detected the downtime. And if we switch over to the Alert Manager tab, we can also see the Alert Manager firing an alert for MySQL not running right now. Now let's have a closer look at the rulebook we got for this lab. So if I look at the rulebook again, it's the same from the last lab, but this time we look at the second rule set down here. So what you can see is we've got a new dedicated port in our sources, which specifies Alert Manager as an event source and does some parsing of data down here. And then we get a set of rules down here, which are handled or evaluated from top to bottom, right? So first, this rule gets evaluated. If it's not a match, this default fallback, which is basically the same as in the last lab, gets run, which will just print the event to our logs. But this is the interesting part now, because here we got a rule named restart MySQL server with a condition of the event alert label's alert name being MySQL not running and the event alert status being firing. And if we take a closer look here on the left to the actually firing alert right now, we can see that this matches the label down here. The firing state will be passed by Alert Manager. That's not one of the labels we can see down here. But that should still trigger this action, which will in turn run a playbook, playbook.yaml. And if we take a closer look at playbook.yaml, we see that it's just restarting the MySQL server with the traditional Ansible playbook, so to say. So let's restart the adder controller and wait for the Alert Manager to actually alert and send the alert to our webhook receiver, and then have a look at what happens. And here we see that actually the event was sent and it was received. You can see that down here. There's a payload of an alert manager receiver event. The status is firing, and the alerts being listed include our MySQL not running alert. And in reaction to this, because it matches our rule as we already inspected, the event-driven Ansible controller will go ahead and actually start this playbook, which contains one play, restart MySQL. It will execute the task, restart MySQL. And then once it's done, we get the recap we already know from traditional Ansible. And if we refresh here on the left side, we will see that MySQL is back up and running again. We did it. We made it through the whole session and the 4 labs. I hope I could show you an impression of what traditional Ansible and event-driven Ansible look like, how it feels to work with Ansible as a tool to automating your infrastructure management and configuration management. And I hope I could share you my vision of using event-driven Ansible for automatic workflows in a maintenance environment. Now I have to tell you that event-driven Ansible is still in a very early stage, so make sure to check out the reference links I will put into the material for today's session in the 90 Days of DevOps repository if you want to learn more about the project, its documentation, how to set it up, a few more examples, or if you even want to contribute yourself. Lots of fun in the following sessions and the remaining days of 90 Days of DevOps.